Good day. I am happy to share our project entitled Enhanced Forecasting Model for Complex Water Supply Systems of the East Service Area of Metro Manila, a project under DOSTP CERD, under the CRADLE program, with our partner collaborator, the Manila Water. I am Chris Monterola from the Asian Institute of Management. In March 2019, Metro Manila suffered one of its worst water crises in decades. We are short by 150 million liters per day. This impacts about 600,000 of our consumers, or 8% of the total Metro Manila residents. 600,000 population is equivalent to about the amount of daily consumption of Metro Manila, Makati and Taguig in particular. This problem of water shortage, however, when you try to understand it, must be balanced with the possibility that if there is too much rainfall, for example, it can also lead to flash floods or loss of lives. So the idea of this particular project is to understand the Angat Ipo La Mesa water supply system, which supplies more than 92% of Metro Manila. All in all, the total consumers reliant on this is about 16.5 million consumers, including those coming from Rizal, Laguna, Cavite, and Bulacan. It also produces 256,000 kilowatt of hydropower electricity and irrigates more than 28,000 hectares of lands in Bulacan and Pampanga. The idea of this work is to forecast the water level of these three systems. It is a multivariate time series problem, which means it includes three variables. And those are among the inputs of this problem. So we have the historical water rainfall. We have the time series irrigation data, the release and the demand in various provinces of Bulacan and Pampanga. Meteorological data that includes daily rainfall and El Nino and La Nina climate index, among others. And there are four things that I would like to highlight with respect to this project. First off, we were able to create an accurate model forecast. The MAE, or the mean absolute error, is about 6.2 meters, which is 260% better than the EVE forecast, which is at 16.1 meters for 1 year horizon. For a shorter horizon, like 30 days, we can have an accuracy of up to 1 meter. The method that we have demonstrated here combines or led by deep learning models like long short-term memory in conjunction with like gradient model and various traditional statistical methods. We have to weight them properly to get the best model result. The second thing that I would like to highlight is that our model is versatile enough to incorporate real-time information. For example, if there is a sudden rainfall spikes, we can include this immediately in the model to make the long-term forecast more accurate. Third, we can do scenario modeling. For example, you are seeing here the actual water supply, level being released in by NIA, by the National Irrigation Authority. And we are simulating here what will happen if you release 1.5 or 50% greater than that, 100% greater than that, or no release at all. And as expected, when you don't release anything, the water level will increase. And if you release more, the water level will decrease. This nonlinear relationship is captured by the model. And the most important of which is that we were able to operationalize this system. We placed this forecasting system in Manila Water's control center. And as you can see, here is the forecasted water level from the National Water Resource Board. This is the internal forecast of Manila Water, the gray one, and our ensemble model forecast is given by the blue one. What is the consequence of this? Note that the ideal water level is the one given by the yellow region. And right now, we are forecasting that we should be expecting the water level to be higher than usual in the coming months. So what are the learning points as a result of this? We have demonstrated here that data science, AI in particular, is a clear driver of innovation to enterprise. In this particular case, we work with Manila Water. And AI and machine learning becomes a competitive advantage for those local businesses who would like to make their presence be felt globally. And this is among the this is very much aligned with the goal of Manila Water. And finally, the triple helix collaboration, the collaboration between the industry, government, and academia can generate real value and impact for all the stakeholders. Thank you so much. And again, in behalf of the team, I'm Christopher Monterola.